Hello everyone, we welcome you all to this Week Tech Tuesday webinar on enabling self-service analytics using IDMC platform, CDMP, CDGC, CDQ and CDI Part 1. Today's speakers are Rebecca South, Srinivasa Gopal and Puneet Dadecha. Before we start the session, let's go through some of the housekeeping tips. The webinar is for 1 hour that includes 15 minutes Q&A. You can post your queries in Q&A box which will be answered at the end of the presentation. All participants will be muted during the presentation. The session will be recorded and it will be available on our InfoSupport YouTube channel and Success Portal where you can download the slide deck. Please feel free to submit your suggestion or feedback for the session in the post-webinar survey. The Success Portal is a micro-learning platform that offers free, unlimited learning to all the registered users. This feature-rich platform helps you learn and adapt to Informatica products better. The following are a few important links that you can go over later. This will help you in your product adoption journey with Informatica. Over to you, Rebecca, Srinivasa, and Puneet. Thank you.
Thank you for that introduction. Let's go through the agenda for today's webinar. In today's session, we're going to cover some of the most common business challenges when it comes to delivering self-service data analytics. This will be a relevant discussion for our customers who are either at the starting line and want to know where to start, or they may be well into their journey and just not seeing much ROI on their cloud modernization efforts. So we will begin today by looking at the challenges to digital transformation as it relates to data quality and data empowerment. We will look at an approach to begin to truly optimize time to insights using cloud data integration, data profiling, and data quality. We'll review specific techniques that will enable trusted data and analytics. After that, we'll share the business outcomes and success criteria that other customers have realized using this solution and approach. And lastly, Puneet Dadecha will do a high-level demo and how to implement a few of the capabilities that drive optimization and data quality. Digital transformation is at the top of every organization's agenda today and continues to place increased demands on chief data officers, chief data analytics officers to really deliver organizational value, either through sharing trusted data that drives insights, innovation, and competitive advantage. However, as organizations have more data, more sources, more structures, more users, more use cases, it's never been harder to make analytics and AI projects work quickly or work efficiently to support their organization's decision-making capabilities. As data literacy has increased, more data users are demanding the visibility to what data is available, whether it can be trusted, how can they get access to it, and how can they collaborate on the data. And when data analysts and data consumers do get access to the data, they often find it stale, it's not fit for their analytics and AI purposes. And furthermore, management is not trusting the data that it's acting on either. So with hundreds of disconnected business processes and data silos, the complexity of technologies and architectures used is driving up the costs to get data into and out of their analytics and AI application. While many data management tools solve one problem, unfortunately, most of these point products don't integrate and interoperate. So it requires multiple solutions, multiple skill sets that are already scarce and adding complexity and inefficiency. So why is this use case growing in criticality? Well, in 2020, a CDO survey conducted by Gartner showed that the top objectives that CDOs are measured on are data quality, their ROI on data and analytics investments, increasing the data sharing across the organization while also optimizing costs. Yet, less than 35% have said they've met these objectives. Furthermore, 72% of executives are saying that fragmented data and poor data quality is the biggest issue for their analytics and AI programs. Less than half of marketers felt confident that they could use their data to improve decision making or better targeting and segmentation of customers or improving customer experiences. Main culprits behind these challenges are difficulty in identifying what data even exists for analytics. It's hard to integrate and cleanse the data. The shape, format, and quality of data varies widely across the organization. This causes challenges to accessing, integrating, and cleansing the data. Some organizations try to address some of these challenges either through manual processing or turning to their data visualization tools. But while the tools are exceptional when it comes to visualization, analysis, and reporting capabilities, they're not really built to solve the underlying data management issues like data quality, integration, sharing, and governance. So most efforts to reshape or cleanse and merge the data sets are usually done through manual, hand-coded, and pretty much siloed efforts. So this is also leading to project delays, increasing the cost to deliver new analytics or AI projects, and it certainly is hindering the analyst community to self-service from any trusted, pre-built, reusable data sets. In this webinar series, we're going to follow the journey of Alex, a senior data analyst of a famous multinational company. And due to various factors, Alex's organization has been going through some ups and downs. And as a result, their attrition rates have been increasing every year. So the head of human services or human resources is looking into this issue. And they asked Alex to create a comprehensive study of internal attrition rates over the last 5 years and provide the length of employment trends while looking at multiple factors such as job position, age group, salary range, gender, and geolocations. And HR is keen to have the insights as quickly as possible because they need to inform the employee retention team where to make investments that will have the most impact. However, they have also stated they don't want to sacrifice accuracy for speed, as poor data quality would result in poor investment decisions. So as a senior analyst, Alex has had enough experience to know she's up against several challenges in delivering this project. First of all, the data needed for the analysis doesn't reside in a single system. So she's going to need to combine multiple source tables in order to have enough data for a meaningful analysis. The data hasn't been profiled to understand how much of it is fit for purpose. Some of the employee records are incomplete or contain bad data. It's coming from legacy systems, and so a lot of that data has been stored in different format types. No standardization on some data fields like dates and locations. Alex is also concerned about how much access she will have to an IT resource or how much time she needs to invest on her end to do merging of data, data quality checks, data cleanup, and deduplication, all of that manually. So she's anticipating it's going to take weeks of massaging the data sources to consolidate them, deduplicate records, and clean up the data to the point she can finally analyze it and report results back to the leadership team. Additionally, Alex wants the final product to be a shared resource in the analyst community and wants to create data quality processes that can be used on future projects to save time and resources going forward. So for the purpose of this webinar series, we are organizing this use case journey into 3 distinct business outcomes. The first one is trusted data with an added focus on optimizing time to insights. The second outcome is defined and governed data using our cloud data catalog and cloud data governance services. And then thirdly is how to use cloud data marketplace for sharing and democratizing data for self-service analytics. In the trusted data journey, we will focus on the optimizing time to insights and data quality for trusted data. Informatica cloud services used in this outcome will be our cloud data integration service, cloud data profiling, and cloud data quality. First, we're going to show how to use CDI and CDP to integrate and assess the initial quality, using automation and pre-built assets to optimize the cleansing processes and build repeatability into the integration pipeline. Then we'll cover in more depth the data quality capabilities that Alex is going to use to improve the overall data quality and create trust in her analytics. In this section, we will look at how to adopt the right tools at the right time, comparing two approaches, one with cloud services, or one without cloud services, and then one with the integrated services that will demonstrate how to optimize time to insights. But first, let's look at why optimizing time to insights is so critical and what is driving this. Organizational pressures to deliver quickly, efficiently, consistently, and accurately have never been more high. And the pressure runs across both IT and the analytics teams to deliver quickly and efficiently. There's a lot of pressure to reduce the project cycles. There is pressure to empower business users to lead the DQ initiatives and free up IT to focus on strategic projects. There is pressure to streamline resolution of data quality issues as quickly as possible with the different business owners. Data governance and data quality efforts need to be aligned with standardized rule definitions and quality thresholds. There's pressure to have consistent application of those data quality rules across the enterprise so that you can reduce work and increase the trust in all the data. Also, leveraging out-of-box AI to reduce development cycles, reduce costs through reuse of centrally managed data quality rules, and then ensuring data quality improvements and ROI can be tracked over time. So let's take a look at our use case, the first one without the benefit of AI or automation. So Alex, the business user, starts with gathering her data requirements for her report. She makes the initial inventory of known systems and what data is needed, and then she submits that request to IT. And thankfully, because of the visibility of the project, she got the resources approved to work on her project. So then IT locates and extracts the data and loads it into the data warehouse for analysis. And typically, IT then creates either the data model or the source table that Alex is going to use for her analysis. And then Alex would likely ingest the data into Power BI for her initial inspection, begin to create her reports. So immediately, Alex notices several data quality issues like missing data, invalid values, and more. So she returns back to IT, having put together some of her additional requirements for cleanup. Now, this step may need additional approvals to bring the IT admin that was assigned back into the project. So there's always a risk there. And then IT will spend a couple weeks to understand the details of the data quality fixes with Alex, manually code those data quality rules into the database, and then IT will republish the data into the final data model again, and Alex will refresh her Power BI reports. Now here the results could be okay, but typically in analytics projects, more issues are uncovered. And then rather than triggering another cycle of change or engaging the IT resources who may not be available at this point, she decides to extract the data into a local file and manually make the remaining changes herself, and then finalize her BI report. Because of the volume of the data, though, Alex isn't quite sure she's caught every instance of the issues within the data model. And so end to end, this round and round has cost several weeks possibly a couple months, hundreds of hours to get to a final report. And furthermore, some of the missing data needed to be fixed by HR operations teams, but they weren't given enough advance notice. So not all the data was fixed in time and therefore couldn't be included in the analysis. So sadly, Alex isn't quite confident in her final report, but she's run out of time to deliver it. So this is where having the right strategy for self-service analytics will begin to truly optimize time to insights. So let's look at an alternative approach that includes cloud data integration, profiling, and quality. So the process starts out the same, with Alex putting together her set of data requirements and submitting the request to IT. So IT will locate the data source and begins the extracts through data integration, but now runs the cloud data profiling task, completing all that in a day or two. Alex has now been given access to the cloud data quality profiling output user interface, so she can access and do the initial review of the results herself. And here she can quickly identify problems with the data, such as missing or duplicate values in the key fields, any inconsistent formatting that's going to impact her summary roll-ups, and any invalid characters in fields where they just don't belong. So now working with IT, they are able within a week to quickly create data quality assets using predefined rule bundles that are available in CDQ to apply cleansing and standardization and fixing the data issues. The advantage of this automated AI-driven approach is that now all of the data will be included in the data quality process, so no records will be missed in the cleanup. Also during this time, an export file of the records that had the missing information was generated and sent to HR operations early enough for them to resolve most or all of the missing gender codes. So meanwhile, IT also created a data integration pipeline that included the profiling and the additional data quality rules defined by Alex that is able to run in a day over all of the data, including any new data that comes in from the integration process. So then IT creates the data model at this point, and now Alex can, with a great deal more confidence, ingest the clean data, build her dashboards, and she eliminates a lot of the round and round and the revision processes. So now, additionally, though, this data integration pipeline will run on a weekly basis and monitor the quality of the data to make sure it remains the same, or it will highlight any issues that come up. But at the end of it all, now Alex is able to publish this data set with high confidence to the other analysts. So she is also able to accomplish another goal. So now that we've looked at how the cloud integration, data profiling, and data quality services can significantly reduce overall project time, cycles, and effort, let's demonstrate how AI and automation can produce data that is trusted through standardized and repeatable processes. Let's walk through the first scenario where our data analyst, Alex, created her analysis off of the first iteration of the data that IT had extracted for her, and then she uploaded into Power BI. So Alex can quickly spot a few problems with the data that tells her this data is not ready to present back to the HR executive teams. Because of lack of the data standards in several fields, there are issues with groupings in 3 of the 4 key metrics, and this analysis is not yet fit for purpose to drive decisions with any degree of confidence or with accuracy. So the state field clearly needs to be cleansed and standardized, as several of the values are not are outside of the standard 2-digit code. She also is seeing some job titles from the legacy systems that's causing some duplication and will need to be standardized. And then she sees that some employee records are missing gender values, and she doesn't really like that gender codes are being displayed in the data set, and she would prefer to have those spelled out. So Alex now has to determine if ICT still has the resources to support these addition of the data cleansing requirements, or she will have to spend the time to do the data cleansing herself. So not only is that time taken away from doing actual analysis, it will be a manual process that may not catch all the errors that are skewing her data, and it will be cleanup on the fly, meaning there's little opportunity to create the reusable cleansing process she needs. So, and because this is a local copy of the data, as we said before, Alex won't be able to publish this data model for other analysts to use. The key to optimizing and creating trusted data is to have a structured, defined approach in place. So as we discussed in the optimizing section, Alex and IT should leverage the cloud data profiling from the start to get an early detection of errors in the data that will help to define the kind of data quality rules that need to be created and the level of effort required kind of based on the number of issues detected. Also, we'll let her know if other teams need to be involved in order to resolve some of the issues. So Alex would have seen here that a significant number of records in the data set are missing the gender codes. She will be able to output those records to a file and send them back to the HR operations team to resolve those issues, then giving them the most amount of time possible early in the process to fix the data before the final analysis is due. Alex is also here able to confirm that a key field that she needs, employee ID, does not contain duplicates. This builds her trust that the data sources have been properly integrated. Another key feature that Alex will use is the Profiling Insights tab, which are data cleansing recommendations that are auto-generated by Informatica's AI engine, Claire. She can review the recommended rules and simply approve which ones she wants to automatically add to the rules that will run in the data profiling tasks the next time she runs the profile. After profiling and understanding the data, Alex knows early on what data will need to be cleansed in order to make it fit for purpose. So Alex decides that report generation will be more efficient if gender codes are changed to a full spelling of male and female. This will ensure the report developers in the future don't have to manually convert the values each time. She saw in the initial profiling that several name records had special characters in them, and some emails did not appear valid. Although she may not need names or emails for this analysis, she has a more strategic goal of creating a published data set that can be reused for future analytics. So Alex will add a cleansing rule that will remove certain special characters, as well as remove any leading or trailing spaces in the name field so that it's all cleaned up for future use. Defining and creating cleansing processes up front will then ensure overall quality downstream when the data is published for use. Alex also needs to provide an analysis by location within the United States, as the HR recruitment team needs to know if the attrition issues are specific to the more competitive markets. She sees that due to the many different sources, the state information is captured in different formats. So she will use the data dictionary feature to create a mapping of the different variations of the state location field to a standardized 2-digit state. She can also make other types of dictionaries where she wants to convert legacy values to current values. So this is a reusable type of asset that can be very valuable to really shaping your data and standardizing it. A fourth option is to add specific data quality rules that can be based on internal business rules or your own data needs. For example, ensuring that fields required for analytics are not blank or null. This can vary across different business practices, and it may or may not be mandatory in some business processes. But for the sake of a specific analytics, null values could deem the record unusable. And so it's important to understand which fields or combination of fields are null. And specific rules can indicate that, can tell you which fields are null, and you can just, Alex can decide if the record has too many missing values and therefore it should just be fully excluded from the final data set and set aside for review by an appropriate business owner. For example, one of Alex's rules was a validity check for employee start and end dates. So Alex wanted to be sure that the end date of an employee did not precede the start date. So she built a rule for that to check for any invalid dates that needed to be sent back to HR for remediation. There are other rules that Alex may decide that she would like to apply either now or down the road. For example, she may decide that within the job title field, she would want to parse out keywords like manager or engineer to provide a better summary and analysis of where attrition rates are trending. There are other tasks she can continue to apply as needed, such as the pre-built verifier asset to confirm emails and verify phone numbers are valid. It can fix the records, and it can even add enrichment like geocoding for global records. The label function can assist Alex with detecting specific character formats, such as foreign words, and add labels, like, for example, French words, or countries, if it has a country-specific format, like a Brazil postal code. And that would be really useful if she is going to be integrating global data sets in the future for her analytics. We won't go into details on these particular features in this session, but in future sessions, deduplicate or talking about the add-on bundles for pre-configuring data quality assets may be discussed. So now that we have a picture of what data quality assets Alex wants and when they need to be applied, we get an idea of how the data integration process is going to work. So you can see where the corrections are taking place. You can see that verification, standardization are happening as the data is coming from the source, and before it reaches that final employee table, the data has been corrected. So this is now saved as a reusable job and will generate the data quality dashboard for Alex to use for continuous monitoring. We'll take a look at that dashboard. So through the Cloud Data Governance service, Alex will be able to view this data set and will be able to look at the data quality dashboard associated with it. So as the data is remediated and pushed through the integration pipeline, the quality results will be reported. And she can visit this dashboard to see as her data is growing within this data set, is the data quality remaining intact? Is it declining, and are there issues that she would need to address? So she can continue to monitor the new records as they are coming in and be assured that the data set remains fit for purpose, especially since it's going to be published to her other analysts. Now let's look at what Alex's dashboard would look like after the data profiling and the data quality rules have been applied. So here you can see now the state labels have been cleaned up and they're all standardized. You can see that the duplication in the job titles has been removed and the roll-ups now look clean. You can also see that the null records on gender have been resolved and the labels are now standardized to the format that Alex is wanting for her report. Now let's take a look at Alex's business outcomes and her plan to measure success. So based on this improved experience, Alex and her Chief Data Analytics Officer teamed with the CDO and the CIO to define and implement a data quality strategy for going forward, one that would have clear goals and specific outcomes, and it would outline the key tenets to achieve those outcomes. So the goals were kept pretty simple. They wanted more efficient operations, and they wanted reliable data analytics. And they put together, again, a plan to achieve this, but keeping it simple in their key tenets. So in order to achieve more efficient operations, they have a plan to automate and simplify through using data profiling from the start, as much as possible, use the pre-built rules and accelerators, and then to ensure they have standardized data quality rules with the data governance team, and that these would be applicable across the enterprise. And then in order to deliver reliable data analytics, they put together a plan for monitoring and reporting on data quality. So driving data observability, so looking at and inspecting the data, the continuous quality monitoring through dashboards and communication, and then implementing remediation processes across the key business data owners. So this is going to be their plan going forward. Alex was also asked to put together some of the KPIs to measure the success of the program going forward. And like a lot of people, Alex kind of struggled with ideas and on what those KPIs should be. So she looked to some actual customer success stories with Informatica products for her inspiration. And let's look at a few of those. So these are some actual customer proof points that have been gathered from customers who are using cloud data quality, cloud data integration, cloud MDM, or MDM, and cloud data governance and data marketplace. So one report that took more than 150 hours to create now takes a fraction of the time. And Alex can certainly relate to that particular success story. And this one as well, saving 100+ hours each week in data discovery for over 11,000 employees. One customer created a one-stop resource where any employee across 70+ locations can access data through Cloud Data Marketplace. Improved analyst productivity by making it easier for them to locate, understand, publish, share the data they need, and also understanding and trusting that it is quality data. And then reducing time, another customer reduced time to generate files for reporting from 6 months to 3 days. So 95% reduction, which is definitely what Alex's and her team's long-term goals would be. So based on some of these stories, Alex was able to develop a scorecard specific to their objectives, their environment, and what they wanted to achieve. So first, she thought about what can be measured. Can she gather baselines, put a process in place to track those projects, and of course, evangelize the results, show the improvements, talk about those improvements. So some of these KPIs that Alex came up with might resonate with you as well. So for her, it was the development cycles that it took for each report, reducing them from their average current rate down to something more manageable. So Alex took some baselines from a recent project she had and compared them to this project, project 2, so that she could at least communicate initially upwards what were some of the improvements just within this project. So time spent on data cleanup, she was able to show a 70% reduction. Time to delivery, same thing. And then initial data quality, Alex decided that she would keep this simple and base it off. How many records did she have to exclude from her first project? How many was she able to fix and reduce the number of exclusions from her second project? And then what were the number of reusable data quality assets that were developed? And assume that each asset saves 20 hours of development time the next round, and the number of published data sets that were produced with a particular project, and assume that each data set may save the next analyst 80 hours. And then she made some other assumptions over in the cost savings column. So looking at the cycle times and the time spent on cleanup and time to delivery, how many days or hours or weeks are saved, and what is that weekly FTE cost, and how many FTEs would be affected and involved in that. So that's how she's going to calculate this. And if possible, she can calculate an estimated value per record, include that as well. So you can see how much she's increasing the value of her data by being able to clean it up and have fewer records that she excludes from her analysis. So I hope this was helpful for you, and thank you so much for your time. I'll now hand it over to Puneet for the demo on cloud data quality.
Thanks, Rebecca, for covering the challenges for analytics being faced by most of the organizations and how we can utilize the Informatica's data quality and CLAIR engine to address some of those. Now it's time to straight away jump to the demo. Just to reiterate the use case, Alex, who is a data analyst, has been asked to create a comprehensive study on internal attrition rate considering hiring and firing in the current market situation by the senior leadership. The analysis needs to cover length of employment trends, looking at multiple factors such as job positions, age groups, salary range, gender, and geographic locations. While Alex starts looking for required data needed for analysis, she finds there are multiple source tables that contain the required data, and there is not a single table that can provide her all the info. She involves the data integration team and provides the requirement to them. Based on the requirement gathering, data integration teams require connections for all the sources path and the target path, build the pipeline, and get her the final table as the EMP final data. This table contains all the necessary fields required for her to kick off her analysis now. Once she starts going through the actual data, she comes across a lot of records that have been blank, errored fields, no standardization, or any sort of data quality checks taken care of already. She understands that most of the blank or misspelled fields such as the incorrect zip code, state, or incomplete SSN need to be corrected by respective source table owners, for which she needs to work with them. However, some of the proactive cleanup can be performed by enhancing the pipeline to include certain data quality cleansing checks, such as cleanup of leading and trailing spaces and special characters in the first, middle, and last name, and standardization of certain columns, and so on. She works with the data integration team to enhance the pipeline to add above data quality checks, after which the EMP final data table is definitely better in quality as compared to before. So here we can see some of the errored rows, such as the last name, first name, and the leading and trailing spaces are there, and the state is not abbreviated in the two letters correctly. So after making the required data quality checks, now we can see the first names, last names, the special characters have been removed, the leading spaces have been taken care, and the state match has been taken care correctly. So for the state, we are using the data quality state dictionary, where we that has been standardized, where all the values need to be replaced as part of column 3. While working on it, still she finds many error.null fields. Now, before she goes back to the source team and asks them to correct the error or null fields, she plans to work with the data quality team to help her set the CDQ profile and rules that will help her figure out the valid and invalid rows for each column. She involves data quality team to help with setup the data quality profile, as well as build certain rule specifications to figure out the exact set of valid and invalid fields. So here we can see the profile created, and we can see the null values, null percentage, distinct values, distinct percentage, and other distributions for each of the column. So we can click on any of the column to see the frequency values, the distinct values, and based on either the frequency or the value based. Also, we can see the graphical representation and check for the values. So, and on the right hand pane, we can see the trend, data type patterns, and the most frequent values. So now the next part is creating the rule specifications. Here for this demo, I have added 5 rule specifications. Like we can see the SSN uniqueness check, rule email validation, higher did check, state length dictionary, and zip length. So just to show here this rule email validation, which is something I have set up as a rule, and for the logic, I have added a maplet, which is nothing but I'm parsing the email address in the email format, and if that format is there gets parsed as required, we specify that as valid, else it is invalid. Similarly, for the rule higher check, I'm validating that the hire date needs to be lesser than the end date uh, in case of ex-employees, or else it's less than the current date. So once the profile is executed along with the rules, we can see the valid and invalid values that come up in the results. So here, let's go back to the summary. So here we can see that for the various rules, the rules that are available. So maybe we can check for one of the rule here, which is the email validation. So here we can see that there are the 9 out of total values, there are 98 are valid values and 9 are invalid values. We select the invalid and hit apply. Once we hit apply, it will show us all the 9 invalid rows. We can see there are 9 invalid rows. And once we now check the email addresses, we can see all those as invalid or null values. Now, once we generate, we can generate the scorecards on top of the rule specifications that we have added. For this, we need to create the rule occurrences and define the rule occurrence threshold. Like we have created a rule occurrence on top of the rule specification, and we define the thresholds as. So here I've defined the threshold as 95 to 100 for good, 85 to 94.99 is acceptable, and below that is not acceptable. So for this, we need to create the rule occurrence and define the rule thresholds, as I mentioned already. So one thing that you might have noticed is the dimension here. So for each of the rule occurrence that we create, there is a dimension that needs to be required against which the scorecards can be measured. So here for the rule higher, I have checked the dimension as accuracy. Similarly, it could be either of the 6 dimensions that we see here, that are accuracy, validity, completeness, consistency, uniqueness, and timeliness, depending upon the rule type or the rule specification. Another important thing that I would like to highlight here is the insights that we see here. So whenever you execute the profile, the Informatica Clear AI engine suggests you the insight rules based on the column name and the data in the column. So you can accept the insights by approving, and once you approve, so we can like approve it, reject it. Once it's approved, it can be rejected. So once we approve it, you will see it as in the approved state, and the rule will automatically get added to the rules. And once you run the profile again, you will see the results available in the results section. Now, going back to the matrices, once the rule occurrences have been added onto the profile and saved, execute the profile again. So once complete, click on the View Scorecard button, and it will generate the scorecard in the CDGC, or the Cloud Data Governance and Catalog tab. So here we can see like the scorecard generated, which is every latest score by dimensions, number of rule occurrences, and we can see all those rule occurrences as per the dimension score as per the threshold score we defined. And there is a dimension for each of them, and accordingly you can see those graphs. So here we can see the trend percentage, which will keep on changing as per the changes in the percentage. Like if the next completeness check is below 90, then we can see this down arrow turning down along with the change in the percentage. So now the other part is here we can see the valid and invalid values for each of the rule. So like once we click the valid or failed rows, we can do a preview of failed rows. So let's do for the zip code validation. So here, once we do that, for the zip code, we see that there are 9 failed rows coming up, and like once we scroll, we can see all the failed rows here, which is like 9 gold, which is like not matching the criteria of either it is special characters or it's not the 5-digit as per the US standards. So this is how like the scorecards can be generated in the CDGC. So now that Alex can see a complete set of failed rows, she can simply take an export and share with the source team and have it corrected. So once the source team updates it, the next schedule load will be cleaner as compared to the current run, and thus data quality improves with each iteration. So now, based on the clean, stable, and updated data, Alex was able to generate a Power BI report for as per her analysis and share the report. So here, like we can see the report is generated and it's an interactive report. So let's take let me select a state. So here I've selected a state where I can see all the other graphs getting updated. So here for the gender, we can see that for this particular state, Nebraska, there were 2 females employed, and they were in the scheduling assistant area, and the salary range was in the 100K group. So this is how the overall process was automated. Now, thanks everyone for attending the session today. Now, let's get back to the QA session for any of the open questions.
Hi all, we have reached the Q&A part. Please post your question.
There is one question from Jack Srinivasan. Where is this Power BI report data originating from? It's coming from a Snowflake database that we had used for storing the data, but it can be any report that you are looking for where this analytics use case can be executed. So. Just want to iterate on the analytics use case here. There are multiple services of IDMC being used here, CDI and CDQ. This shows that now for a functional use case, you can use various IDMC services. Currently, we are using as a part one as cloud data integration and cloud data quality. You can leverage for the use case that you're driving with, for various services that IDMC provides. If your ARC is enabled with those services. There is another question from Vikas. Can you explain the difference between rule template and rule occurrence? It's being answered by Puneet. So that's similar to a standard rule where you apply the rule template is similar to apply as a standard to a higher grain, like a business term, and rule occurrence is like a local data quality rule where you apply to an individual attribute or column. That's the rule occurrence.
If you have any questions, please post an Ask Question toolbox.
There is one question from Rohit Reddy that where is the profiling process data stored? So for this, in the Informatica Cloud platform, there is a dedicated profiling warehouse that is on the AWS side, on which all the profiling results are stored. So there is a complete architecture diagram that we can share, and that has been shared in the previous TTs as well. So please feel free to reach out to your CSM, and they can engage the customer success architect, and we can have the detailed discussion with you in that regard.
Any more questions? All right, we will end the session. Thank you, Rebecca, Puneet, and Srini for presenting today's webinar. We request audience to take up the survey and let us know your thoughts. Today's webinar will be available tomorrow in Success Portal under the Resources tab. You all have a great day ahead.